Hi everyone, this is the walkthrough for Pillar of Truth by Bill Murphy. This will be guessed at some point, but it hasn't been published yet, so I don't know what date it's for, but by the time it's published, you will. So this is a row indexer puzzle. We have normal Sudoku rules, of course, 1 to 9 in each row, column, and box. Additionally, Bill says marked cells, a marked cell in row X, indicates which row X appears. So what that means is we have an 8 here. It's in row 2. So that means the 2 in this column is in row 8. These reference each other. And we're always going to get that with row indexing. We're either going to get pairs that reference back to each other. So row 8 is in, 8 is in row 2, 2 is in row 8, 8 is in row 2. Back and forth, or we're going to have a self-referential digit. So 3 in row 3 tells us 3 is in row 3, which we already knew. And in fact, every column is going to have exactly one self-referential digit because this is a global constraint. This isn't really relevant for solving this puzzle, but it's kind of interesting, so I will mention it. We have 9 cells in a column, so we can't have all pairs of referencing digits. We have an odd number total. So we can have 8 digits that are in pairs, but we're always going to be left with at least one that references itself. However, you can only have one self-referential digit in each row because it is the digit corresponding to that row. So if we need at least one in every column, and we only have at most one in every row, we're going to end up with exactly one in every column. So kind of interesting. You could probably use it in a few places, but you're not going to need that for a gas version. So just thought I would mention it. But to get started, I'm just going to go row by row with our given digits. We have quite a few given digits, and most of them are going to give us immediate placements because of what they're indexing. And by going row by row, I can easily keep track of what digit I'm placing each time. So as long as I'm in row 2, I'm placing 2s, in this case in row 8, because of this 8 here. Now I'm in row 3. 3 is in row 3. That's already taken care of. We have a 7, which tells us 3 is in row 7. That's also already taken care of. But this 8 gives us a 3 in row 8 in this column. So these are in the same column. Row 4, the 2 gives a 4 in row 2. The 3 gives a 4 in row 3. And the 7 gives a 4 in row 7. In row 5, we have row 1. We have row 4. We have row 6. And we have row 9. In row 6, we have row 3. We have row 4. We already took care of row 5. So this 6 placed a 5 here. That 5 is looking back at the same 6. The 8 is going to place a 6 in row 8. In row 7, we have 2, so 7 in row 2. The 3 is already taken care of by this 7, and this 7 references itself. And then finally in row 8, we have a 5, so that's going to place an 8 in row 5. Okay, let's look across the middle row, since we already have 5 digits there. And I can see that, well, there's a couple of ways we could look at this. We could look at it as a hidden single. There are 3s in these places, ruling 3 out of these cells. So there's a 3 here. We could also look at it as a naked single. So we need 2, 3, 5, and 7. We have 2, 3, 5 here, so that gives us a 7 there. We know there's a 3 here because that's the only place for 3. Either way you want to look at that, this row is fully resolvable. This 2 tells us this is a 5 and this is a 2. And now we're going to go back and look at those digits that we placed because those are indexing digits. So the 7 gives us a 5 in row 7. The 5 is self-indexing. The 2 gives us a 5 in row 2. And the 3 gives a 5 in row 3. and we have done all the 5s now. And we know we've done all the 5s because we've completed row 5. All right, what next? In this box, we still need an 8, but there's an 8 here. So we've got 8 in row 4, giving us a 4 in row 8. These are 6 and 9. One of these is self-referencing. The other is going to place a 6 in one of these cells. In the central box, we still need a 7. We've got a 7 there. So 7 goes here. That is referencing a 6 in row 7. And then these are 1 and 9. But we can see we have a 6-9 pair here. So this is our 1, which gives us a 6 in row 1. This is our 9, which gives a 4 in row 9. Now these are 1 and 4. Don't know the order yet, but that's going to give us a 2 here. Placing 6 in row 2 by indexing. This box, I need 1, 2, 8, and 9, and I have 3 of those digits, so this is going to be 1, giving a 7 in row 1. And that's going to make this a 4, which is our self-referential digit. This is a 1, placing a 4 in row 1. We have 2, 8, and 9 left. I don't think we can resolve that yet. This row we need 1, 2, and 9, and these ones are forcing the 1 here. It's going to give it 3 in row 1. And then these are 2 and 9. We don't know the order yet. Oh, we do know the order. There's the 2 right there. Those pesky invisible givens. All right, this is row 3, so we need a 3 in row 2, 3 in row 9. The 6 is going to be our self-referential digit. And we should have all the 3s now. This is a 9, so that's going to place a 6 here. We should have all our 6s. We should have all our 4s. And the reason I know this, again, is the row is complete. So since all of these are row indexing, we should have all of that digit. In row 2, we need 1, 2, and 9. Don't think we can resolve it directly, but we can resolve in this box. We need 2 and 9, and there's a 2 way down here. So that's 9, giving a 1 in row 9. This is 2, self-referencing. Now these are 1 and 9, but we have a 9 here, sorry. So that gives us a 2 in row 1. This 9 gives us a 2 in row 9. That should be all the 2s. This is an 8, so that gives a 1 in row 8. And this is a 1, self-referential. That's all the 1s. We need 8 and 9 in row 7. The 8 gives us 7 in row 8. The 9 gives us 7 in row 9. This last digit is 8, and that is self-referential. Our last 8 is going to go here, referencing 9. And finally, we have our self-referential 9. And yeah, so if we mark all of our self-referential digits, you can see that these appear in different columns. Let's make them pink. But it's a gentle example of a global indexing puzzle. These can be very hard if you don't have very much information. So Bill was very kind to us with this. But that's the solution.